Today we're going to look at transformations in symmetry, and this former student is going to be illustrating one type of transformation that we are going to be talking about today, and she is going down a slide at the City Museum in St. Louis. If you've never been to the City Museum in St. Louis, I highly recommend that you go. It's amazing. It's basically a giant Burger King play place for big kids. So it's a lot of fun, and I definitely recommend going the next time you're in St. Louis. First of all, what is a transformation? A transformation is an operation or a moving of a figure to a new figure called the image. And when I see the word transformation, it makes me think of the word Transformers. So like Optimus Prime and Bumblebee and those kind of guys. And that works out really well because in Transformers, they are still the same character the whole time. They may be in a different spot or kind of sound a little bit different, but it's still Bumblebee, it's still Optimus Prime the whole entire time. The first transformation we're going to examine is a reflection. And I want you, when you look at the word reflection, to look at the FL in reflection and think about the FL in the word flip, because that's what you're doing. You're making a mirror image or a flip of your figure. So this triangle has been flipped over the purple dotted line. Again, reflections are mirror images. So here we have a bird in a reflection. It's still the exact same bird. It didn't suddenly lose a wing or grow a third eye in the middle of its forehead when it started looking in the mirror. It's the exact same. A line of symmetry. A line of symmetry is a line that divides a figure into two congruent equal parts that are mirror images of each other. Now this can happen in a couple different ways. It can be that the line of symmetry is outside the figure. For example, this green figure here can be reflected over this line and have that line of reflection or line of symmetry, it means both, can be that over here. So if there was a mirror on this line, you could tell that both pieces were the same. You can also have a line of symmetry that's through an object. For example, for my letter X over here, I have a line of symmetry that's a horizontal line of symmetry. And you can also have a line of symmetry that's a vertical line of symmetry. With this particular figure, we also have diagonal lines of symmetry as well. This can be folded in half, or a mirror could be placed on this line, and it would be exactly the same as just having the other half of the figure there. We've already done the X, so I'm going to take that out. But looking at the other figures, I want you to predict how many lines of symmetry each figure has. Pause your video at this point. Did you identify the correct number of symmetries? This star is going to have 5 because there's 5 different points of the star, and each one of those can be a line of symmetry. For example, here's one of the lines of symmetry. We'll pretend that that's a little bit straighter. Our last type of transformation symmetry, our second type of transformational symmetry is a translation or a slide. And that just means to slide or move an object from one spot to the next. This star, for example, I can translate or slide this to the upper right-hand corner, to the bottom right-hand corner, just a little bit to the side of this. You can translate this in infinitely many different ways, but it's still the exact same star. I haven't changed it in any fundamental way. All I've done is moved where it is. Our final, now this one's our final, I promise this time. Our final symmetry that we are going to be examining is a rotational symmetry. And rotation just means to turn your object. For rotational symmetry, we have to be able to fit the object back on top of itself. So for example, this triangle has 1, 2, 3 rotational symmetries because it fits back on top of itself 3 times. So therefore it has rotational symmetry. For your homework tonight, you need to draw an example or find a real-world example for the three types of symmetry: reflectional symmetry, translational symmetry, and rotational symmetry. Here's an example of each one. First of all, for reflectional symmetry, you can't use these since I already have, but for reflectional symmetry, think about a mirror. We've already talked about that. Translational symmetry, think about the cha-cha slide. When you're dancing at the school dance to the cha-cha slide, it wants you to slide to the left, slide to the right. You didn't suddenly gain 300 pounds or lose a fingernail as you slide from one side to the other. Hopefully you didn't, at least. If you're dancing dangerously, you might lose a fingernail, but typically you're going to be the exact same person in the exact same form that you were when you slid from one side to the other, so you were symmetrical to yourself still. For rotational symmetry, I always think of this object here. This is one of those little block containers that my nephew loves to play with. And thankfully, these have rotational symmetry. If they didn't, he would probably get pretty frustrated trying to put the star inside the star shape because he'd have to turn it so many times before it would go in. So that's an object with rotational symmetry. Make sure to have these done for tomorrow.